Alright, so in this video we're going to be talking about area, more specifically area of quadrilaterals. And just so you guys know, I decided to break these videos up into about 6 different videos. The first one is going to be quadrilaterals 1 and 2. Then I'll do triangles 1 and 2 and circles 1 and 2. Now the 1 version of all these videos, like this one, it's just going to talk about the basic formula on how to find area for that shape. Okay, now quadrilaterals, it's more than one shape. We're talking about a few different shapes, and I have the more common ones listed right here. But anyway, so we're going to be talking about just the basic formula, some basic geometry concepts, and then in the 2, for example, quadrilaterals 2, and it'll be the same for for the other ones too. But the 2 means that we're going to be applying more algebra into the geometry component. So those are the kinds of problems that tend to be more difficult. So if you're like, anyway, this will be the most common kind of things you might see for maybe high school level or your high school equivalency like the GED. Okay, just to give you a heads up. So be on the lookout for the next videos and understand how they work, the 1 and 2. The 1 is the basics, the 2 is a little bit more interesting, perhaps a little bit more difficult, and you'll probably need to know your algebra. Okay? Alright, cool. So, quadrilaterals. 1. Okay, quadrilaterals. I put a basic definition here. I said that quadrilaterals are two-dimensional shapes that have 4 sides. I mean, that's why we have the whole quad. That's what quad means, right? It means 4. So, okay, that's basically what it is. Remember two-dimensional shapes. Two-dimensional shapes have a base and they have a height. They have a this and they have a that. Okay? Some people say it's a length and a width, whatever, you know, but it's this and this. Okay? Alright. So the most common quadrilaterals that we'll see typically at this level of math is a square, a rectangle, a parallelogram, and then a trapezoid. Those are the most common that we usually see. I know it might be a little bit hard to see on the screen. I will be making them bigger later, but I did put little marks on the square, and I put these little, well, also on the square, I put these little boxes in the corners. What do those mean? And I put this little dotted line with another one of those little weird boxes, and the same thing over here with a little weird box. What does that mean? Okay, we're going to be talking about that today. So, yeah, two-dimensional figure with 4 sides, okay? Now remember that when we talked about 2 dimensions and 1 dimension, I'm going to reference this thing that I put on this little board. Remember that 1 dimension, we're talking about perimeter. 2 dimensions, that's what we're talking about now. We're talking about something squared, units squared, feet squared, inches squared, miles squared, yards squared, whatever squared. Later we'll be talking about volume, okay? But like I said, these first 6 videos are just going to be about area. We're just going to be talking about 2 dimensions, okay? Alright. Cool. So, I'll go ahead and erase this and we'll get started. So, let's start off with the first shape, a square. What is a square anyway? Do you guys know what a square is? Okay, a square. It sounds easy, right? It sounds like, well, duh, it's a square. Everybody knows what a square is. But if you had to describe it to somebody from another planet, what would you say? How would you do it? Would you use your hands? Would you just say it's like a box? What would you say? How do you define a square? Well, you can't say box because box is a 3-dimensional shape. So we can't do that. You know, remember, 3 dimensions are containers, basically, so you can put stuff in a box. You can't put stuff in a square. Okay, it doesn't work the same way. So a square is a quadrilateral, 4 sides, that all of its sides measure the same. So if like the base of the square measures, or the length of the square measures 3, all the other sides also measure 3. That's one of the characteristics of a square. Same sides, or they measure the same anyway, right? And all the angles that, you know, that the 4 sides make, they're all 90 degrees. Very important characteristic of a square. Okay, so cool. Let's draw one here. Let's see. And I apologize, I'm not the best drawer or the best artist, okay, so bear with me. But I'm going to say this is a square. And I'll even add some more information. I'll put these little symbols right here. So first off, these little boxes that I'm putting in the corners, they represent 90 degrees. They represent that the angles that those two lines form, or the angle that those two lines form, for example, this line and this line, they make a 90-degree angle. How can I show that? They make the 90-degree angle, okay? And that's important, okay? Because we know that a square needs to have 90-degree angles. Anyway, so these little boxes mean 90 degrees, okay? The next thing we should look at here are these little marks that I put through through each side. What does that mean? It means that the side that has one mark on it will measure the same as all the other sides that also have one mark. Okay? Let's compare that to like a rectangle, for example. Let's see. I could show you something like this. Well, it's supposed to be a rectangle. I'll put my little right angles here so you know that it's supposed to be a rectangle. Okay, so we know it's a rectangle-ish, right? But another thing we need to know is well, actually, that's enough information there to know that it's a rectangle. But I could do this, right? So this is saying that the side that has one mark on it measures the same as the other side that also has one mark. And vice versa, or the same thing goes for the sides that have two marks. They measure the same, okay? So this is a thing that you might see sometimes in your geometry books, geometry tests maybe. But it's important to know what they mean at least, right? Get the idea down what it means. I don't know what this measures, but I know that whatever this one measures the same. I don't know what this one measures, but I do know that whatever it measures, if it measures 4 inches, this one also measures 4 inches. That's what it's trying to communicate. So in a square, all 4 are the same because it's a square. I mean, we know that about squares. All 4 sides measure the same. Okay, I think I've said that enough. All right, so let's go ahead and talk more about this. Let's go ahead and put some measurements here. I think that's enough. I think that's enough, right? Because I know, like I just said, if this one measures 2, that one measures 2, this one measures 2, and this other one on the side here will measure 2 inches. All right. Well, let's talk about area. We need a formula to find the area, okay? And the basic formula that I like to use is base times height. And for now, I'll leave it in capital letters. Base times height. Some books, well, the other one, if I was to write it with algebra, I would probably use lowercase letters and put the B and the H right next to each other to show that they're multiplied. In other words, I don't need to use the little multiplication symbol anymore. In algebra, we just write them together, okay? And that shows that they're multiplied. Base times height. In a lot of math books that I see, they use this. They use S squared. S stands for side squared. Because squares have all the sides the same, you could just say, well, like, for example, if it was base times height, for example, this would be my base, this would be my height, and actually, I need to put another one here. Let me move the S squared down a little bit. Okay. So all 4 of these are basically saying the same thing when we talk about squares. Some books will use length times width. I was taught with base times height, so I like base times height because that's what I know best. More familiar with, I guess. But a lot of books will use length times width. Don't get so caught up on the words, okay? It's this times this. It's one dimension times the other dimension. That's it. You can call it Benjamin times Noah. You know, don't worry about the name so much. It's more about the concept of what you're actually talking about. Area is 2 dimensions, okay? So most quadrilaterals will have a length, a base, whatever you want to call it, and they'll have some kind of height or a width. But it's this times this. That's it. Don't overthink it, okay? So anyway, base times height, length times width, if you like it, But a lot of books for squares, they like to use this formula, s squared. I don't use this one, and I'll tell you why. Because this formula will be the same for rectangles, this formula will be the same for parallelograms, and you can also use it for squares. So I'd prefer to use one formula for 3 shapes instead of like 3 formulas for 3 shapes. I like to simplify things. I can use the base times height across the board. Well, except for the trapezoid, but we'll get to that. So you see what I'm saying? And the reason why they say this is because, well, if the side measures 2, then it would be 2 squared. And 2 squared is equal to 4. If I was to use the base times height, right, the base times height thing, well, 2 is the base, and the height also measures 2, so 2 times 2, that also equals 4. You get the same answer. Well, I should put inches squared on both of these, because we are talking about area. We did multiply 2 dimensions. Okay, so, yeah, I mean, it's the same thing. I don't know, 2 times 2 or 2 squared. I don't like this formula. And be aware that they do something very similar for cubes when we do volume, okay? They go s cubed. So you're multiplying 3 dimensions. Well, we're not there yet. I'm just giving you a heads up. So I don't like that formula, but look at the formulas that are in your book and make your comparisons and see which ones you want to use. You can use what I use, whatever, all right? It's up to you. So basically, we already found the area. This square measures, the area of this square is 4 inches squared. Okay, you can either use this formula or any one of those, it doesn't matter. Okay, moving on. All right. Okay, what about the next shape? The next shape is something that looks like this. Okay, I can do something like this. We'll call this one feet. Oops, feet. Okay. That looks horrible. All right, I feel better. All right, so we have this rectangle. Okay. It measures 8 by 4. Remember, I only need one representative of the dimension. We know that this measures 8 and that the top measures 8 as well. But I don't need to use, I don't need doubles of these numbers, right? I don't need to have an 8 over here and I don't need to have a 4 over here when I'm talking about area. Perimeter, I do. Perimeter, I need all 4. Remember that. Remember that video on perimeter. But for area, I only need one thing that will represent from this side to this side, and I only need one number or one distance that will measure from the bottom to the top, or the top to the bottom, whatever how you want to look at it. I need one of these and one of those. I don't need the doubles, okay? So don't get that confused. So I'll go ahead and put my formula down. And like I said before, it's the same formula. You can use length times width or base times height, but it's the same for all of them. I don't like the s squared, just to let you know. So I'll use my base as 8 times my height is 4, and that will give me 32 feet squared. Squared because we multiplied 2 dimensions, base and height, or length and width, okay? So that's it. I'm not going to get too much more into this. Again, this is just the first video of quadrilaterals. I almost dropped my marker. Just the first one. The next one will get more interesting, okay? But it is important to know the formulas. Try to memorize these formulas. It'll save you a lot of time. So the next shape we have, to cover. There we go. Let's go ahead and put some of these guys on there too. All right. So this is a parallelogram. All right. Parallelograms used to be rectangles, and then the wind just kind of blew them over. That's it. But you can imagine it just like a rectangle. Okay. In a rectangle, the top measures the same as the bottom. Same thing with the parallelogram. The top measures the same as the bottom. Because they were, you can imagine it was a rectangle and it just got blew over by the wind or something, okay? So, that tells me that this measures 10 on top, the bottom will also measure the same, 10, okay? Height, what's the height? Some students want to use the 5, some students want to use the 4. Who's right? Right? Who's right with that? Is it the 5 that measures the height, or is it the 4? How many of you were one of those families that would, where their parents would measure the height of their children every birthday, and they'd probably do it on the kitchen wall or something, and you know, here's little Madeline when she was 5, and here's little Madeline when she was 6. Did you ever do that? Or do you do that with your kids today? I don't know. When you did, if you were the kid being measured, how did you stand up? Did you stand up all like leaning back on the wall like that? I almost fell over. Or did you stand up straight up? It's almost on your tippy toes, right? Because you know that the straighter you stand, the taller the more accurate that height is. So it's the same thing here. Okay, we're not going to use these sides that are inclined or tilted over, because if I was to stand this 5 up, it would be a lot higher. It would measure more than the actual height of the parallelogram. Okay, so that's too high. I mean, that's more. We want to use one that's straight up and down. And again, this is what that little box means. That little 90 degrees. And typically, if they don't put the box, they will put the dotted line. That much for sure they will do. So you need to know that. Okay, very important. Look for that straight up and down. Okay? All right. So, but again, it's not too crazy hard. We're not doing anything too wild in this video. It's the same formula, base times height. So it's pretty cool. The square, the rectangle, and the parallelogram, they're all base times height. Okay, just to simplify one formula for all 3. So, base times height. My base is 10, because what is on the top is on the bottom, that whole rectangle thing, okay? Oops, is that right? No, it's not right. Put the 5 instead of the 4. And I should be putting my units. Let's call these yards. I always forget. All right, you guys get the idea. Yards. Okay, so 10 times 4 is equal to 40 yards. Is that right? Nope, it's not right. Why not? Right, because I didn't put my square. I have to put squared. If I didn't put that little 2 there, the answer is showing one dimension only, like perimeter, like a distance around something, and you can just stretch it out, and it's just from here to here, one dimension. You don't want that. You need to put that squared. You have to put the squared, otherwise you're not talking about area. Okay, just to let you know. All right, so there's parallelograms. They're all the same in that they use the same formula, base times height. Be careful about the height. Look for the straight up and down. Usually a dotted line accompanied by a little square. If there's no square, at least they'll give you the dotted line, okay? All right. So make sure you write down your formula for all 3 shapes. It's this one. I prefer just that, but if you like length times width, whatever, okay? It's just the this times the that. Whatever you want to name them, I don't care. But now the formula is going to change, okay? We're going to talk about a different shape now. We're going to be talking about this shape that looks like this. And my little box, because that's going to be my true height. So, okay, I have pretty much, let's call this 4. Let's call this 10. I'm not going to put these angled ones to confuse you right now. You already know that for area, we don't need those inclined or those angled sides. We just need the one that's straight up and down right here. That's going to be the one we need, okay? For a perimeter, now, yeah, you would definitely need to know what these measure, right? Because, yeah, well, this perimeter is the sum of all sides, correct? Okay. Just giving you a little, refresher on what we had talked about. Now, the formula is different with this one, okay? The formula goes like this. Base 1 plus base 2, and I'll go ahead and use another set of parentheses, times the height. I'll put the h in lowercase, but it's height. All that divided by 2. Okay? And that's it. Now some books do this. pretty much the same thing. I'll put parentheses here again for the h. I prefer to divide by 2 than to multiply by 1/2. It's the same. It'll give you the same answer, but I don't use this one. I prefer just to do all that first and then cut it in half, divide it by 2. So again, look in your books, ask your teacher. I mean, look at the formulas that are available to you, and try to make sense of why they might look different than with the ones that I'm using. But these ones work just as well. Okay. All right. So I'm not going to use this one. I will use that one. So I'm going to first start off with my formula blank, I guess, my skeleton of the formula, I guess, which will be something like this. Okay, that's basically what my formula is without any of the numbers. Obviously, I got to put a number here, and a number here, and then do all the steps. Now, before we get into this, you got to go back and remember order of operations, okay? Because this is a multi-step problem. There's parentheses, there's a division, there's multiplication. You got to know which one comes first. So I did make a video on that, order of operations. Check it out, okay? So check it out if any of this doesn't make sense, okay? All right. So my base 1. Now remember, I have 2 bases. I have 2 lines that run like this, right? One's a little bit shorter and one's a little bit longer. But it doesn't matter which one you want to call base 1 or base 2, because you're just going to add them up anyway. So, anyway, my first one I'll say it's 10, base 1, the one from here to here, and then my base 2 will be the one from here to here. So that'll be 6. Okay. Or you can put 6 first and 10 second. It doesn't matter. 6 plus 10 is the same as 10 plus 6, right? So that's 16. Now my height is going to be 4, okay? Again, I didn't put other extra numbers here to confuse you, but we already know to look for that one that goes straight up and down. So that's 4, that's my height. So order of operations dictates that we have to do what is inside the parentheses. Now you could say I have 2 pairs of parentheses, but over here, there's nothing I can do inside. It's just a number 4 and that's it. So there's really nothing to do. But over here, yeah, there's definitely something that I can do. There's this addition that I have to do. So that's what we do first, okay? So 10 plus 6 is 16. How much space do I got here? Okay, 16. And I'll go ahead and leave the parentheses for now. All right, so then we have 16 times 4. Uh-oh, that's a big number, I don't know. So 16 times 4, is it 64? Yeah, I think it is 64. So let's go ahead. Now we do the multiplication, and then the last step will be the division. No, it's not 64. Let me see what that is. You know, it's okay to, if you don't know something, you got to do it sometimes by hand just to make sure it is 64. Okay. Had to check. All right. So, do I have room down here? Can I go down here? Yeah, I can. Oops. So 16 times 4 is 64. Divided by 2. All right. And then the division. Did I say feet? I always forget. Now, this time I'm just going to put U. A letter U for units. Squared. Okay, that unit could mean anything. It could be yards or miles or kilometers or centimeters, whatever. Okay? So the area of the trapezoid is 32 units squared. Okay? So it's just a couple of steps. Your base 1 and base 2 are these 2 that run parallel. They run in the same direction. They're just different lengths. It's a hard one for me to say, lengths. Okay. And so you add them together first. Then you multiply by the height. Then you divide all that by 2. Okay? And that's it. So that's pretty much all I have for you today as far as my lesson goes. Oh, and again, it's okay to do stuff by hand. Okay? Don't feel bad. You got to use your fingers and toes. That's okay too. The idea is to get the answer. That's it. But as usual, I have a couple of examples that I want you to try on your own. There we go. Okay, so I have this shape here, and this one I want area and perimeter. Okay, that's what the A and the P mean, area and perimeter. And then down here I'm just asking for area. Okay, so go ahead and pause the video, give it a shot, be honest, do your best. All right, so how did it go? Did you do it? Did it work? Hope it did. Not too bad, not too hard. Okay, so let's do the first one here. I think I can just do it right here. So, I like to put down my formula, okay? I'm going to use the classic base times height. Okay, now, what kind of shape is this? This is a square. And how do we know that? Because all the sides measure the same. They gave me the measurement of one side, and then they put all these lines through each of them, or one line through each of them. And that means that if they have one line, they measure 5. They measure the same as the one that has a measurement. Does that make sense? Okay, so this is just 5 times 5. And that would be inches squared. Okay, so that's my area, 25 inches squared. And then perimeter, remember that perimeter is the addition of all the sides, okay, or the sum of all sides. So there's 4 sides in quadrilaterals, so we're going to add up all 4 of those. And 5 plus 5 plus 5 plus 5, or you could say 5 times 4 would be 20. Okay, and remember that we do not put squared because perimeter is one dimension, and that's all we're showing here, inches, one dimension. It's like from here to here, it's just one line. The area is the this times the that, the length times the width, the base times the height, okay? All right, cool, so that's what you should have got. Now down here we have a trapezoid, and again, I always like to start with the formula. I'll go ahead and put it here. It is base 1 plus base 2 times the height divided by 2. Okay? So if I was to put my little skeleton version of that, I would put probably my fraction bar, parentheses, addition, parentheses. Okay, well that's good enough. Oh, and my 2. Divided by 2, the 2 is there, it's a constant. Okay, so what are my 2 bases? The 2 lines that are parallel to each other. One's shorter, one's longer, doesn't matter which one's base 1 or base 2. So this time I'll flip-flop from the last one that we did. I'll call this 8 base 1, and I'll call the 12 base 2. Why not? It doesn't matter, I'm going to add them up anyway. And then times the height, okay, 6. Remember that the little 1 mark like that, doop, and doop, and doop, that means feet, okay? Especially like in a contractor schematic or blueprint or something like that. They always use that 1 little mark to show feet. If it had 2, like this, doop, that would be inches. Just to know, I've said that before, but I know I like to repeat myself. Okay, so moving on, back to the formula here. We do what's inside the parentheses first, so 8 plus 12 is 20, right? And then we have to do the multiplication, 20 times 6. That's like 2 times 6 with the 0 on the end of it, so 2 times 6 is 12, with the 0 is 120. I think I got enough space for one more line here, 120. And then 120 divided by 2 is equal to 60. All right, so my area is 60 feet, I'll go ahead and write it out this time, feet squared. Okay. So, two-dimensional objects, quadrilaterals, the most common ones are the ones that we talked about today, square, rectangle, parallelogram, and trapezoid. We just went over the basic formulas, nothing more. Try to memorize the formulas. Try to find a formula that works for you, a formula that you can maintain in your brain, one that you can remember and access easily. I tried to simplify it by saying that the square, the rectangle, and the trapezoid, and the parallelogram, not the trapezoid. Let me say that again. The square, the rectangle, and the parallelogram can use the same formula. Be aware that in your books, they sometimes like to use more than one formula. Okay, they like to say a square is s squared. a rectangle is length times width. And, well, I guess a parallelogram would also be length times width, or base times height. A lot of books use length times width nowadays. When I grew up, it was base times height. So keep that in mind. Again, try to find one that works for you, one that you can understand. Okay, so keep practicing. Be on the lookout for the more difficult problems of quadrilaterals. That'll be Quadrilaterals 2. Okay, so good luck, keep trying, and see you on the flip side.